Problem number 17. In figure, let the mass of the block be 8.5 kilogram and the angle theta be 30 degree. Find the tension in the cord. Find the normal force acting on the block. And if the cord is cut, find the magnitude of the resulting acceleration of the block. So here we have to answer for these three questions. First of all, let's rewrite the given, and then we have to draw the free body diagram for the information given in the question. So let's rewrite the given first. In this question, the mass of the block is given, that is M equal to 8.5 kilogram, and the angle theta is given as 30 degree, and we have to draw the free body diagram. By that we can answer one by one. So here we had a block in the inclined plane, and the angle here they mentioned as 30 degree. So the block is kept on the inclined plane, and this block is attached by using a string or cord to the wall. So the mass of the block is 8.5 kilogram, and this block is tied by a string or a thin wire to the wall. And we have to consider the surface between the block as well as the inclined plane are free from friction. Now, if you draw the free body diagram, the force acting perpendicular to the surface of the object is a normal force, which is F of n. And then this is a force due to gravity, which is mg. And when you see here, the inclined plane is kept at an angle of 30 degree. By that, you have two components of the gravity force, which is mg cosine theta, and here this is mg sine theta. Now you can see the upward force, which is equal to downward force. To frame the equation, by that we can get the answer for each question. So what is given in the first question? We have to find the tension in the cord. That means you can see, if you want to find the tension, we have the cord here. So this is the cord. The cord is nothing but a thin string is connected to the block, and the another end of the string is connected to the wall. So that means if you connected the block with the string or cord, you have a tension here, right? So that means the tension of the string or tension of the wire will be acting in this direction, and then which is exactly equal to mg sine theta. So we have to equate this equation, right side equation, which is equal to left side. That means the tension, which is equal to mg sine theta. When you use this equation, we can easily find the answer for the tension. That is the answer for our first question. So let's rewrite the answer for the first question. For the first part, we are going to find the tension. So here I have to consider the right force which is equal to the leftward force, which is the tension equal to mg sine theta. So T equal to mg sine theta. Now the value of the mass and the gravity and the theta is already given. So the mass value is 8.5 multiplied by 9.8 multiplied by a sine of 30 degree. So here I got the answer as 41.65 Newton. So that's the answer for our A part, right? In the B part, what they asked, we have to find the normal force acting on the block. That means the upward force, which is equal to the downward force. That means you have to see here my Fn, which is exactly equal to mg cosine theta, right? So I have to use this equation for finding the normal force. So by that we can get the answer for the second part. That is our B question. So Fn, which is equal to mg cosine theta, and the mass value is 8.5 multiplied by 9.8, that gravity value, multiplied by cosine of 30 degree. Here I got the answer as 72.14 Newton, which is our normal force. So this is the answer for B part. Now in the third part, what they said, if the wire is cut, what will happen? The block will be accelerating in this direction. That means which direction? In the direction of mg sine theta, the block will be accelerate. But they ask you to give the answer of the magnitude of the acceleration. That means we have to consider the direction. If you see this diagram, this is the direction of the positive x-axis and this is the direction of the negative x direction. That means when you cut this string or the cord, what will happen? The block will be accelerating in the direction of mg sine theta. That is nothing but the negative direction of the x, right? So that's the reason they ask in the question, you have to give the answer of the magnitude of the acceleration. Actually, here the acceleration value is negative. Why negative? Because once you cut the cord, the block will be accelerating in the direction of mg sine theta. So this direction, the block will be accelerate. But if you give the axis detail, so this is your positive direction of the x, this will be the negative direction of the x. By the time, the answer for the acceleration here we got as negative. But what we have to do? We have to give the answer of the magnitude of the acceleration. So now what I'm going to do? I'm going to give the answer for part C. If the cord is cut, what will happen? The block accelerates in the direction of mg sine theta only. Clear? So that means we have to equate the mg sine theta with a Newton's second law. So what is Newton's second law? F is equal to ma, and here the acceleration direction force is F is equal to mg sine theta, but here mg sine theta is in the direction of the negative x-axis, so we have to put a negative sign here. Clear? Now the left side of the two equations are same, so we can equate the right hand side of the equation. Therefore m multiplied by a is equal to minus mg sine theta. So we can cancel mass both left hand side and the right hand side, and then what is remaining? We got the equation for acceleration. So what is remaining? Acceleration a equal to minus g sine theta. Now I'm going to substitute the value minus 9.8 multiplied by sine of 30 degree. We got the answer here as minus 4.9 meter per second square. That's the answer for part C, but they ask you to give the answer of the magnitude of the acceleration. So therefore the magnitude of the acceleration, which is equal to positive value of 4.9 meter per second square. So this is the answer for this question. Thank you.